Hello everyone. Today I have another example related to resistors combinations, and as you can see in this circuit I have 6 resistors being distributed or connected, as you can see from the chart. Now I'm looking for the total or the net resistors or the equivalent resistor for in this circuit. Also I need to calculate the total current going through the entire circuit, and lastly I need to find the current going through each resistor and the voltage across each resistor. Alright, so as I mentioned previously in different videos, to find the R equivalent, that means I am shrinking or simplifying my circuit. To do this, I will start from the opposite side of the battery, so I'll go to R2 with R4. These two resistors connected in series. As you can see, it's an end to end, and I will call their equivalent as R equivalent 1, and in series we add them up, so 2 plus 4, that will give me 6 ohm. Then I will have R4 with an resistor 3. Also again they are end to end, so they are in series, and they will give me my second equivalent, and it's gonna be 9 ohm. Now if I look at that, it looks like I have this equivalent 1, and this is my equivalent 2, and it's connected with my circuit this way. This one is already gone, done with them. So I will have resistor 1 with R equivalent 1 and R equivalent 2 and the resistor 6. Now to do that, I can see that's R equivalent 1 with an R equivalent 2. They are parallel, and they will give me the third equivalent resistor. Now for the parallel resistors, as we know, we say okay, it's 1 over 6 plus 1 over 9. Then we have to find the inverse. To do that, it will give me 3.4 ohm. Great. Now my circuit will look like this. This is the resistor 1, this is the equivalent 3, and this is my last resistor, which is 6. Equivalent 3, and this is number 6. And you can see they are connected in series. Should be very simple to find the total or the net or the equivalent for the entire resistor. So simply I will add them up, which is 1 plus 3.4 plus 6, and this will give me 10.4 ohm. Okay, so here I can see that I found how much, or calculated how much is the equivalent resistor for the whole circuit. So my circuit now look like this. It's just the battery with one resistor, 12 volt, and the R equivalent, which is 10.4 ohm. It's a simple circuit. That's the idea of finding the R equivalent, to simplify our circuit. Now for the second part, which is finding the total current going through the resistor, it's like you putting an ammeter here, which also is going to be in, like for the original circuit, you just kind of like placing an ammeter here to measure how much is the total current or the full current going through the circuit before any resistor, right? And that should be very easy, following Ohm's law. And current, we can say here total equal the voltage divided on the equivalent, and that will be 12. Sorry, let's fix this one quickly. This is 12 divided on a 10.4. That will give me my total current. And it is 1.15 ampere. That's the total current going through this circuit. Okay, now for the last item in this question is to calculate or finding the current going through each resistor and the voltage across each resistor. this is going to happen as a combination, finding the current and the voltage for every single resistor as we go. To do this, we have to reverse the process. So I'm now, after I shrink my circuit, I have to expand my circuit step by step, starting. So we found the total current, then I will reverse it back to this point here when I have the resistor 1 with the equivalent 3 and resistor 6, they are in series. Then I will remember the concept. When I have resistors in series, they will have the same current, but they will share the voltage, which means these three resistors here, resistor 1, equivalent 3, and R6, will have the same total current, which is 1.15 ampere. But they have to share that 12 voltage between them, depending on how much is the resistor. To do that, we'll go to another page. All right, so this is what I have. So I can say the current total equal to current of resistor 1, the same current of the equivalent 3, also the same value of the resistor of 6, which is 1.115 ampere. Great. Now, these my three resistors. Okay, they will share the voltage. How to do that? Also, again, it's following Ohm's law. So the voltage R1 and the voltage for the equivalent 3, and here is the voltage of R6. Simply, I will multiply the current 115 multiplied with the original value of R1. I have it written beside me, it's 1, and that will give me 1.15 volt. Again, 115 multiplied with the equivalent, which is 3.4. That will give me 6.9 volt. It's almost 7 volt. And for the last one here on this series, it's 6 ohm, and that will give me 3.91 volt. All right, so if we round them like to 7, and here is almost 4, and you add them up, they will give you almost a 12 volt, which is the original voltage coming through the battery. Okay, so now I found the current going through resistor 1 and the current going through resistor 6 and the voltage across each one of these two. Now, the next step of this expansion is this equivalent 3. So I will go step back and I can say, all right, this is our equivalent 3. Our equivalent 3 was the combination of our equivalent 1 and 2, equivalent 2, sorry, parallel, right? Okay, so let's go to that one. So here is my R equivalent 3, which is the combination of R equivalent 1 and R equivalent 2. Great. Now, here for this R equivalent 3, I have to ask myself, what do I know about R equivalent 3? I know the magnitude, it's a 3.4 ohm. I know also the voltage of R equivalent 3, which is being calculated here. It's 6.9 volt. Great. I need one thing missing for me. It's how much is the current going through R equivalent 3. If I want to calculate that, or I've been asked to calculate that, I can do that. It's not that hard. But it's not my focus. I need to find how much is the current and the voltage through each single resistor. So what I'll do, because R equivalent 1 and R equivalent 2, they are parallel, they will have the same voltage of R equivalent 3. So it's the same voltage for R equivalent 1 and also the same voltage for R equivalent 2. So I know their voltage. Here we go. Let's ask, so for R equivalent, resistor equivalent 1, I know the magnitude. I have it calculated before. Same for equivalent 2. I know their voltage. I can find how much is the current going through R equivalent 1, which is the voltage over the magnitude of resistor equivalent 1, and this one I can calculate it. It will be 0.65 ampere. All right. Now, how much is the current going through equivalent to? It's the voltage, which is the same voltage, but it's different equivalent. We can check that. It was the equivalent to, it was 9 ohm. Now, to calculate that, that will give me 1.12. Oh, sorry. No. Just erase that a bit quickly. It will give me, for this one, let's calculate. Yeah, it's gonna be 0.49 ampere. Okay, so if you add them up, they should give you back about 1.115 ampere, which is the original current we know they will share. Okay, so now I know how much is the voltage across R equivalent 1 and how much is the voltage across R equivalent 2, their current going through each branch of these two. All right, now the next step is to expand each one of these to R equivalent 1. So R equivalent 1, it's originally coming from the combination series of resistor 2 and resistor 4. Okay, now let's do this quick. Because the resistor 2 and 4, they are in series, they will have the same current going through R equivalent 1, which is 0.065. So it's going to be the same current for R2 and also the same current going through R4, which is 0.65. Now, to calculate how much is the voltage, we're just going to follow Ohm's law, and that will give me this. The voltage of R equivalent, sorry, R resistor 2 will be the current multiplied by R2, and that will give me 1.12 volt. For the voltage across R4, again, it's the same current, which is the 0.65 multiplied by the resistor 4, which is 4 ohm, and that will give me 2.6 volt. All right, and if I add these two voltages together, they should give me back the original voltage across them. Okay, now for sorry, let's go to the last one, which is R equivalent 4. It's the combination of R 3 and R5. It's a repetitive to the R equivalent, equivalent 2, the repetitive to R equivalent 1. And that will give you, that's the current going through them. Equal 0.049 ampere. Yep. And for the voltage of R3 and the voltage of R5, simply following Ohm's law, that will give me 1.47 volt, and here 2.45 volt. Okay, this is the way to do this kind of like circuits. By reaching this stage, you're already back to the original chart of your circuit after you expand it. I hope you find this example useful, and I will see you again with another one. Thank you.